We decided to do our project on section 15.2 of the book, which focuses on optimization and local and global extrema.
So first, let's look at what global maxima and minima are. So they are basically just the highest and lowest points on the 3D graphs, similar to how it would be the highest and lowest points on the 2D graphs.
So to find local minima and maxima, you just find the critical points of F in the region R and investigate whether the critical points have a global maxima or minima. If the region R has a boundary, you can investigate whether F attains a global maximum or minimum on the boundary of R also.
So the extreme value theorem guarantees a function to have both global maximum and global minimum over a closed and bounded domain. A closed region is one that contains a boundary, and the bounded region is one which does not stretch to infinity in any direction.
So we decided to do an example problem, and this is the problem we picked. So the quantity of a product demanded by consumers is a function of its price. The quantity of one product demanded may also depend on the price of other products. For example, if the only chocolate shop in town, a monopoly, sells milk and dark chocolates, the price it sets for each affects the demand of the other. The quantities demanded, Q1 and Q2, of two products depend on their prices, P1 and P2, as follows. So for part A, the question is, what does the fact that the coefficients of P1 and P2 are negative tell you? And we said that the price and quantity are inversely related, which means that the price of as the price of the good increases, demand decreases, giving one of them, price in this case, a negative coefficient. And you can see in the graph on the right the inverse relationship between price and quantity demanded.
Okay, so part B was, if one manufacturer sells both products, how should the prices be set to generate the maximum possible revenue? What is that maximum possible revenue? So the first step of this is to figure out the equation for revenue. Revenue is the price times the quantity of both of the different goods. So for this, we just basically took the price and multiplied it by the function that we were given for the quantity. So then to find the maximum possible revenue, you want to take the partial derivative of the revenue with respect to P1 and then with P2. So I have those solved out here on the slide. And the partial derivative for P1 is 150 minus 4P1 minus 2P2. And the partial derivative for P2 is negative 2P1 minus 6P2 plus 200. So then the next step is to set each partial derivative equal to 0 and then find P1 and P2 using substitution. Doing that, you get that P1 and P2 both equal 25. So you want to plug that back into the revenue to get the total revenue. The total revenue that we got was $4,375.
So one of the reasons that we were interested in this topic was due to its real-world applications. So here's one example of a topographical map of Maine, and you can see the highest and lowest points of the state, which are indicated by the colors. So the highest point will be like the orangish colors around the western border, and the lowest points are obviously closest to sea at sea level.
Thank you for listening.